Hello and welcome to the TranSpec technical webinar. My name is Dr. William Mortimer and I'd like to thank you for joining us. The webinar has been set up so that you'll be muted throughout the presentation. Any questions either during or after can be asked using the Questions tab on the GoToWebinar toolbar down the right hand side. Any questions will be answered at the end of the webinar. This webinar is a follow-on from the previous technical introduction webinar and will be around 20 minutes long. If you have not seen the previous webinar, the link will be provided at the end of the presentation. There will be a brief recap on TranSpec's technology in this webinar. I will then discuss the options TranSpec offers in terms of spectrometers and packages, followed by an overview of the types of application that TranSpec can be used for. We will then discuss in more detail some of the examples of identification, quantification and property prediction, as well as material assessment before concluding. This webinar will be looking into the application of TranSpec, but before we go into this in more detail, it's worth taking some time to first start to think about the type of application you would like to use it for. So what is it that you want to measure? Before jumping into measurements, you first need to think about what exactly is the issue. What properties are related to this, for example? This could be part of it is breaking, and this in turn could be related to the mechanical strength and the brittleness. Next we might want to think about how could we measure this and whether we have a good range of samples to cover these properties. And then we need to think about the materials being used and their chemistries. The key unique features of TranSpec is its ability to link high quality spectral data to the metrics of interest, thus turning data into knowledge. It is the TransChem software that can look for these correlations between spectra and properties of interest that are not possible by simple methods. Because many metrics can be linked to the spectra, multiple property measurements can be made. This allows analysis that takes seconds to complete to give an array of measurements and predictions, saving time and money. The TranSpec process involving building a database where calibration samples are entered rapidly, which can either be produced or come from historic samples. The properties of interest are then added and a model can then be built using the TranSchem software. The models can then be tested with blind or unknown samples to validate. TranSpec has been developed by Gnosis due to our interest in polymer analysis, where we carry out work from consultancy to research programs, analytical services to method and instrument development. There are currently two options for TranSpec spectrometers, TranSpec Raman and TranSpec Wide Wavelength. Both give high quality spectral information. Raman uses laser excitation and has a spectral range of 175 to 3200 wavelengths, which is wide enough to pick up heavier atom vibrations such as bromine, and in general Raman tends to give sharper peaks in the wide wavelength, which along with its high resolution helps in unravelling peak assignments of complex mixtures. TranSpec Wide Wavelength uses light reflectance and covers the UV vis to NIR region. There are a variety of probes for liquids, solids and textured surfaces, and is particularly useful for looking at dispersion and colour issues. Both systems are portable and can give complementary high quality spectral data. The choice of system will depend on the application, but in general TranSpec Raman would be expected to meet the needs of compounders and master batches. Spectroscopic analysis is a very powerful tool as it gives molecular information rapidly and thus gives chemical information relating to bonds. This puts it ahead of techniques such as XRF and atomic absorption, where only elemental information can be gathered. The molecular vibrations seen in spectroscopy are not only governed by the atoms attached but also by the environment, so there will also be relationships to crystallinity, density and moisture, for example. The intensity of these peaks can also be related to the concentration of the materials, so quantifying components is also possible. So, as we can see, this spectral information is very powerful, as information can be gathered on the molecules, environment and concentration. But historically this information has not been fully utilised, with typical analysis involving peak assignment to ID materials, spectral overlays from libraries, but a lot of the detailed information stored is wasted. TranSpec aims to unlock and utilise this information to maximise your knowledge. When we look at the information desired by plastics users for analysis, we see that this information is held within the spectral data. Matrix ID such as polymer ID, materials qualification, through to detailed analysis of the polymer to reveal grades. Additive ID and concentration, again through detailed analysis of the data. Properties are then linked to this, and dispersion issues can be looked at through variance as well as changing the analysis setup. And colour can also be seen, measured through the visible spectral region. It is these types of analysis that TranSpec is designed to tackle through choice of spectrometer and software setup to meet specific requirements. There is no instrument that can cover all these requirements straight from the box, but TranSpec gives you the tools to tackle these requirements. Obviously, today's complex formulations with multiple components mean that this is not a simple task, but with our software the relevant parts can be pulled out of the data. For the measurements to be made, databases of the desired materials must be built, and from these new materials can then be measured. It is the ability to tackle these complex issues with simple to use software that allow cutting edge measurements to be made. Depending on the types of measurements made, a whole range of applications are opened up. From a production point of view, quality control of incoming and outgoing materials is vital for meeting customer specifications. Quality assurance methods are linked in throughout manufacturing, and the rapid nature of the measurements means that analysis is either near line for checking production or can be adapted to inline to give real-time measurements, revealing issues as soon as possible. Options are also available for certification for customers and in some cases compliance for legislation such as WEEE. Because more detailed information can be correlated to properties, there is much scope for TranSpec as a tool for research and development, for relating performance to formulation, spotting trends, and generally accumulating knowledge and building databases. There is also the option to use TranSpec for IP policing and protection. I will now discuss in a little more detail some of the applications, starting with quality control. This can be particularly important for incoming materials, where early spotting of variation in the polymer grades and linking this to physical properties, such as melt flow index, can be vital to the following processing steps. The same is true for additives, where the ability to evidence issues back to suppliers and prevent poor material being compounded is beneficial. Aging can also be an issue, where perhaps moisture uptake or degradation occur over time to the raw materials. Quality assurance methods can also be widely adapted for incoming materials, processing and outgoing checks. TranSpec's portability means that point and shoot measurements can be carried out in the warehouse, off-site or in a laboratory. Typically near line is considered to be a measurement made as quickly as possible from production, but in many cases this involves sending to a laboratory, which involves delays and costs. TranSpec can be on site to make measurements rapidly. There's also the option for online measurement to give real-time feedback if optical fibres can be connected to processing equipment. This would offer the possibility to optimise processing during production. Identification and qualification is a very powerful, quick check that can be done for incoming material. For example, does it match what was ordered? Does it match the previous batches? Are there any impurities present? Or has it aged over time? And for idea of components and formulations, has a mistake been made? Or can I prove to the customer that the specifications have been met? It also has applications for competitor analysis. We can now look into more detail on the types of applications suited to TranSpec's benefits. An example of high molecular discrimination is the area of brominated flame retardant analysis, as this has historically been a very tricky analysis, as the compounds are very similar and the concentration levels can be low. Alternative analysis such as XRF can only give elemental information, for example. Bromine concentration, not identification of the flame retardant, and infrared based techniques do not have the spectral range to pick up the brominated bonds. TranSpec's high molecular discrimination means that it can be used to identify a wide range of compounds accurately. The graph above shows the different brominated flame retardants and how their spectra differ. Quantification is a vital part of master batches and compounders analysis, as it can give information on incoming polymer material such as blend and grade analysis, for example the ratio of polycarbonate to ABS, as well as additive control. By checking the level of flame retardants and other expensive additives, the compounder can save both time and material costs, whilst making sure customer requirements and standards are met. This graph shows a model that carries on from the previous identification of type of brominated flame retardant. TranSpec has built a model of the concentration of the additive within the matrix, which is validated and can then be used on unknown samples. The graph shows the actual concentration against the concentration measured by TranSpec, and the regression coefficient shows the region of the spectra that are feeding the model, in this case specific bromine bonds. Gnosis can carry out this model building step for you, or you can do it internally with some training with the software. Once a model is built, the routine analysis requires only a very basic training.